Hi guys, we are going to begin radicals. This is a little bit difficult and confusing, but once you understand it, you're going to do really, really well. So make sure you pause and think every time you see something new that you're having trouble understanding. So, the first thing we want to do is teach you how to simplify radicals. And in order to simplify radicals, you need to know your perfect squares. So, remember your perfect squares, such as 1, 4, 9, 16, 25, and so on. And not only are we going to do numbers, we're also going to do variables. So, to simplify a radical expression, you have to make sure the radicand, which is the number inside the radical, has no perfect square factors other than 1. There should be no fractions inside the radical, and there should be no radicals in the denominator of the fraction. So, for example, this one is simplified, this one is simplified, and the third one is simplified. However, radical 12 can be simplified further. The second one has a fraction, and the last one has a radical in the denominator, which you cannot have. So let's try simplifying some radicals. So the rule is that the multiplication property says that if A is positive or 0 and B is positive or 0, then the square root of A times B can be separated into two parts. So we can make it radical A times radical B. For example, the square root of 48, also known as radical 48, can be split into two parts, radical 16 times radical 3. Now, we can break it up into many factors, but the goal is to always look for a perfect square in the factors. And I see this one has an extra m. Okay, so 48 is 16 times 3, so we're going to split it into 16 and 3, radical 16 times radical 3. And radical 16, of course, is 4 because the square root of 16 is 4, and then times radical 3. Now, when we are dealing with radicals, we are not going to look at the negative square root. We only want to deal with the positive square root. So let's try the first one. What is radical 160? So at this moment, you need to think about which perfect square times and a number will give me 160. And it turns out that 160 is the product of 16 times 10. And I've highlighted the perfect square here, which is 16. So we're going to separate the two, and once you've separated it, you know that radical 16 is going to be 4. So it'll be 4 times radical 10. Now 10 cannot be simplified any further because the factors of 10 are just 2 and 5, and neither one of them are perfect squares. Here's the next one. What is radical 72? So I'm going to break it up into a perfect square times a number, which is 9 times 8. And 9 times 8 becomes, and then I separate it, and radical 9 we know is 3. However, 8 also contains a perfect square, so it's 4 times 2 is 8. So it becomes 3 times 2 radical 2, which becomes simplified to 6 radical 2. Remember, whatever you leave inside the radical should not be able to simplify any further. There should be no more perfect squares in there. Now, maybe you can start trying the next one, except that this one has a variable, but you can figure out the first part. So, 500, I'm going to break it up into 100. First, I'm going to break these two apart, and 500 is going to become 100 times 5. And x cube is also made up of a perfect square. It says over here that split it into as many x squares as possible. So it becomes x squared times 3. And then 100 becomes 10 times radical 5. And x squared comes out as just x, radical x. And we're going to multiply out what's outside the radical and multiply what is inside the radical together. And we get 10x times radical 5x. Okay. See if you can try this on your own and then take a look. So 54 is 9 is first I'm separating the two, and 54 is 9 times 6. 9 is a perfect square, and n to the 7th has many perfect squares in it. So I'm going to just separate it, and each one of these n squares is going to come out of the radical as a n. So we have 3 radical 6 and n times radical n. Remember to multiply what's outside. 3n cubed times 6 radical 6n. All right, here's something a little bit different. We have two numbers that are outside the radical already. So what we're going to do is we're going to multiply those together. I think I've just rewritten them. And so it becomes 2 times 3, and then the rest will go inside together, which becomes like so. I broke up the 14 into 7 times 2t squared. So you can see it's 7 times 7, which is going to be 49. So the 2 times 3 became 6. The 7 times 7 will come out as just 7. And then the t square is also a perfect square, so it comes out as a t. And inside we are left with 2t. So we multiply out whatever is outside, and 42t times radical 2t. Here's another one, and now it starts getting a little bit more complicated. So 6 doesn't have any perfect squares inside, but 18 does. So we're going to put the two radicals together. Actually, maybe not. I took out the 9. Yes, I did put it together, and then the 9 is a perfect square. So that 9 is going to come out as 3 times 3. And inside, we're going to be left with 6 times 2. However, 6 itself is made up of 2 times 3, and then there's a times 2, which makes it 2 times 2 is 4, which is a perfect square. So the 4 will come out as a 2, and you're left with radical 3. And then simplify 18 radical 3. Here's another one. And this time we're just going to put everything inside one radical and then look at it carefully. 9 times 2 is 18, right? But 9 is a perfect square. So we're going to we're going to keep the 9, and then we're going to put a times a to the third is a to the fourth. So I'm going to break it up into two squares, which gives me 3a squared radical 2. Okay, like I said, this is a confusing lesson. Do your best. Don't think I have anything more than this for you. I just want you to think about this one a little bit. What happens when we have powers, odd powers and even powers on a negative number? So which of these will be negative? Let's see if you can figure it out. These are your answers. Okay, and just keep that in mind. And that is it for today. Goodbye.